Hi guys, so in this video I'm going to be explaining how to find the shape of any molecule or ion. So the first thing you're going to need to do is draw the Lewis structure following the Lewis structure rules, and then after that you're going to find the format of the molecule, if that makes sense, in the form of AXNEM, and from there you just refer to the shape rules. So we'll start with PCl5. First we need to find the number of valence electrons. We know that P is in group 5 and Cl is in group 7, so the total number of valence electrons is 5 plus 7 times the subscript, which is 5, for a total of 40 valence electrons. So we'll start by drawing P as a central atom connected to every Cl with a single bond, and then we'll put 6 electrons around each outer atom to fill the octet. Okay, now that we're done filling the octet of all the outer atoms, we're going to count the number of electrons we've drawn and see how many we have left. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and 40. We have a total of 40 valence electrons, and we have 40 represented, so nothing is going to be put on the central atom. This is AX5, which if you refer to the shape rules, is trigonal bipyramidal. And that is a symmetrical shape, so it's nonpolar. Next up, SO2. There are a few molecules that we work with very often that you should know the shape of automatically without drawing. These are SO2 and H2O, which are both V-shaped. You should also know that CO2 is linear. And you should know NH3 is trigonal pyramidal. So I'm not going to be covering how to find the shape of those, you should know them automatically, but I will be going over O3. So we draw the oxygen with the two other oxygens as the outer atoms, and we start filling the octet. Remember that we have a total of 3 times 6, because 3 O's, of 18 valence electrons, filling the octet of the outer atom here. This is 2, 4, 6, 8, 10, 12, 14, 16. So we have 2 electrons left over, which we will put on the central atom. This is AX2E, which is V-shaped, if you refer to the shape rules. If they ask you to draw the proper Lewis structure, however, you have to make sure that this central O has 8 around it, and you can do that by removing a lone pair on one of the outer atoms and making that bond a double bond. As you can see here, there are 2 resonance structures. The double bond can be here or it can be here. Moving on, we have PCl4, so find the number of electrons first, 5 plus 7 times 4. And the charge is plus 1, so we're going to subtract 1 electron, because plus 1 means that the molecule has lost 1 electron. So 5 plus 28, 33 minus 1, for a total of 32 valence electrons. We'll start drawing the structure. Remember that, again, if they ask you to draw the Lewis structure of an ion, you have to put the ion in brackets and put the charge outside. But for determining the shape, that doesn't really matter. Filling the octet of the outer atom here. Outer atoms. And once we're done, we're going to check how many electrons we've already drawn. So all of this is 8, 16, 24, and 32. We have no electrons left. So this is in the format AX4, which is tetrahedral, and it's a non-polar shape, but remember that ions are always polar regardless of their shape. Next up is PCl6. You should know this automatically. It's in the format AX6. We've only learned one shape for AX6, which is octahedral. Next up, XeF2. Xenon is in group 8, so it has 8 valence electrons, plus 2 times 7, because fluorine is in group 7. So that is 8 plus 14 for a total of 22 valence electrons. We'll draw xenon in the middle, connected to the 2 fluorines by single bonds. Fill the octet of the fluorine. these are 16 electrons, leaving us with 6 electrons, which we will put in the form of 3 lone pairs on the central atom. This is AX2E3, which is linear, and it is non-polar. Alright, next up, SF4. Again, this is one of the molecules you should know automatically the shape of. It is seesaw shaped, but I'm going to show you how to do it. So 6 plus 4 times 7, 28 plus 6, so 34 valence electrons. So we'll draw S as the central atom connected to the 4 Fs by single bonds. Fill the octet of the fluorines. So this is 32 electrons. We have 2 left over that we'll put as a lone pair on the central atom. This is AX4E, which is seesaw, and it's a polar shape, so this molecule is polar. Next up, ClF3. This is one of the things you should know. Any halogen bonded to 3 other halogens is T-shaped. That is a rule. IF4, any halogen bonded to 4 other halogens is square planar. And for IF5, any halogen bonded to 5 other halogens is square pyramidal, as shown here. The lone pair vertically below the plane repels these fluorines from below, and this fluorine repels the fluorines from above, so you end up with a square base with the fluorine vertically above the central atom, so it's going to look like a square pyramid, if you can visualize that. Next up, SCl2, 6 plus 2 times 7, meaning we have 20 valence electrons. We'll draw the S as the central atom connected to the 2 Cl's, and we'll start filling the octet. You can represent the electrons as dots or crosses. It is completely up to you. So 16, and we have 4 valence electrons left over, which we will put on the central atom in the form of 2 lone pairs. This will be AX2E2, which is V-shaped. It's a polar shape, and this molecule will be polar. Next up, Cn minus. Whenever you have two different atoms bonded together, it's always polar because it's a single bond, a single dipole vector, so the net dipole will not be equal to 0. But I'm going to show you how to draw the Lewis structure so that if it comes as a question in the exam, you won't get it wrong. So 4 plus 5, and since the charge is -1, plus 1. Remember to always put ions in brackets with their charge outside. And we'll start by filling the octet of the N. So we have 10 electrons, this is 8, so we'll put the rest up on carbon. But this is wrong because carbon needs 8 around it, so we'll start removing lone pairs off the nitrogen, and we'll make this a double bond. Still not enough, so we're going to remove, one more lone pair off the nitrogen, make this a triple bond. So this is how Cn minus looks. The last one we're going to go over today in this video is NO3 minus. So the total number of valence electrons is 5 plus 3 times 6 plus 1 because the charge is -1. So 18 plus 5 is 23 plus 1, 24 valence electrons. We'll draw the N as the central atom bonded to 3 O's. Fill the octet of the outer atoms. And now we check how many now we check how many electrons we have left. 8, 16, 24. We have no electrons left. If they ask you to draw the correct Lewis structure, you're going to need to take one of the lone pairs off one of the oxygens and make that bond there a double bond. This double bond can be here, or it can be here, or it can be here. So NO3 minus has 3 resonance structures. Thank you.